Okay, here are your notes on parabolas. So, we saw in the ellipse and in the hyperbola that you have this D1 that is perpendicular from a directrix to a point on your graph, and this D2 that goes to the focus. And in a parabola, the definition of a parabola is that D1 will always equal D2. That distance always stays constant, so that means the ratio of D2 over D1 is going to equal 1, and that means the eccentricity of a parabola is always 1, because D2 over D1 defines your eccentricity. Okay, so you have two orientations for your parabola. You have the vertical position where it's opening up or down, and that has a standard form translated that looks like this: y minus k equals 1 over 4p x minus h squared. So the y equals x squared is what we're used to seeing. Sometimes you'll see this 4p move to the other side, but I rarely ever write it that way. So we know from before that if p, so 1 over 4p is just like a coefficient, and we'll talk about what p means. But if your coefficient is positive, your graph is a smile. If p is negative, your graph is a frown. Okay? And you have your vertex, hk, and the focal length. Now here we're changing, we're not going to use c anymore. That focal length is going to be p. And it matters that the direction, so from the vertex to the focus, that's a direction of p. And so that means in terms of a coordinate, you have the direction h. If we're going up and down, the k value will be adding p to it. Now the directrix is going to be exactly the same distance away from the vertex, so that's going to be a distance of minus p, but your directrix is the equation of a line. So this is going to be a y equals, and if your vertex was at the origin, it would be y equals negative p. Depending what the k value is for your coordinate, it'll be k minus p. So this would be y equals, so it's just basically the exact same distance from the vertex on the other side of the focus. All right, so let me see, what else can we say? Oh, to give yourself, rather than plotting a lot of points to establish how wide your graph is, turns out there is something called the latus rectum. It's a lovely name, I know, but it comes off of the focus perpendicularly, straight over to your graph, and it is a distance of 2p and 2p. So in other words, that total distance on your graph is the equivalent of that 4p. So you can just, once you go to your focus, you can just count over 2p, back 2p, and you have the width without having to plot points for your graph. Okay, then we have the other orientation. The other orientation is when you are sideways. So that's usually when you have x equals y squared. So just like before, I tend to write it as the singleton, x minus h, equals 1 over 4p, keep that in front of the squared term. So now y minus k squared. And we know, of course, then if p is positive, your graph is opening up in the positive direction. If p is negative, your graph is going to open up in the negative x direction. And your vertex is still going to be hk. Your focal length is still going to be p. And again, that is the direction from the vertex to the focus. So that would be a positive p. Going backwards would be a negative p. And so our directrix is now going to go back and forth in the x direction. So it'll be h minus p. Sorry, I should really write that. It is the equation of a line. So it's going to be x equals h minus p. And the actual coordinate for your focus is now going to be h plus p comma k. And obviously if p is negative, then everything reverses. But that's sort of your default. Okay, so let's actually do a problem here. Given this equation, we want to, and we're going to keep it the way it is, we're going to identify it, which obviously one squared term, this should be the easiest, we know it's a parabola, and find all this stuff. So one thing I like to do is I like to put all my transformations on one side. So this is y minus 2 equals 1/8 x squared. And so the coordinate of my vertex is going to be 0, 2. So 0, 2. And I know that my orientation is going to be going like this, since my coefficient is positive and it's y equals x squared. So before I can find my coordinates, I notice that 1/8 equals 1/4p. So that tells me that p is a distance of 2. So I'm going to come up a distance of 2 and go back a distance of 2 to draw my directrix. And so now I can see that the coordinate of my focus is going to be 0, 4, and the equation of my directrix is actually y equals 0. The latus rectum distance in totality is 8. My eccentricity is always 1. The focal radius, that was the p value, equaled 2, and that meant the directrix radius was -2. And now to draw the graph, I'm going to go from my focus, so this is the focus, this is the vertex. I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, so that's a total distance of 8. And then you can draw a graph that truly reflects the width of the graph. Okay? So now let's practice a sideways parabola. So if you have a sideways parabola, then it's going to be x equals y squared. So again, I like to put this in sort of an or in its transformation form. So x minus 2 equals 1/2 y squared. And that means that, of course it's a parabola, because that's what we're doing. So my vertex is going to be now 2, 0. So come out here. The coordinate of the focus, well now 4p equals 2, which means that p is 1/2. This is going to be really tight here. So I will come in here for 1/2, and that means 1/2 behind that is going to be my directrix. So the coordinate of my focus, what am I doing? I just did it in the backwards. I'm sorry. This is still going in the positive direction, so let me redraw that. So my vertex was at 2, 0. My focus is half a coordinate forward and half a coordinate behind. There we go. Now all is right with the world. So the coordinate of my focus is 2.5, 0. My directrix is 1, x equals 1.5. Latus rectum distance, that is the 4p, which is 2. Eccentricity is always 1. So my focal radius was 1/2, and directrix is -1/2. That tells you how far you went away from your vertex. And so now from my focus, I'm going to go out 1 in this direction and 1 in this direction for a total of 2. And then just draw the graph. So it means it's going to be a little bit skinnier. Okay, so there's a sideways parabola. All right, last little bit with parabolas is the parametric form. So parabolas actually don't use any of your Pythagorean identities. It's one of the easiest, though it's the one that everyone forgets, because all you're going to do is take whatever your equation is, right? Whatever your equation of a parabola. So here's the two different forms. And wherever the squared term is, you're going to replace it with t, And then you're going to say what that t replaced. So t replaced y if it was vertical, and t replaced x if it was horizontal. And that's pretty much all there is to it. All right, so let's go ahead and do one where we give you the equation and you have to come up, or sorry, we give you a graph and you have to come up with the equation of that graph. Oh, you know what? This had a mistake. No, it didn't. Sorry, I'm thinking of something else. Nope, these are all good. Okay, so I look at this graph and I want to come up with the equation. So I see that my vertex is at 5, 2. So that's going to give me my HK. And I see that my orientation is sideways, which tells me it's going to be sort of x equals minus y squared, or sort of that form. And I can see that I have a particular point here, a particular xy that is at 3, 0. So we're going to go to our general form, and that looks like x minus h equals, now instead of 1 over 4p, because I don't really have anything with the focus and the directrix, I'm just going to write a, which is the coefficient. It serves the same thing as 1 over 4p. So here's my generic equation. So I happen to know that hk is 5, 2, so I can plug that in. X minus 5 equals a, y minus 2 squared. And then I also happen to know that I have a point on my parabola. So I know that 3 minus 5 equals a, 0 minus 2 squared. And now I'm just going to go through and solve for a. So this is a negative 2, and this is 4. So we get that a is going to be a negative 1/2. And then you just put it all together. So we have x minus 5 equals negative 1/4 y minus 2 squared. And if I wanted the parametric form of that, I would write x equals, I can move the 5 over, 5 minus 1/4, y is going to get replaced with t, and then I specify that y is now t. And that's it. You're done. Okay, last little bit is solving the quadratic systems, which is really just about solving algebraic problems. So as you can see from the diagrams, you can have all kinds of different intersections. I can have no intersection, one intersection, two intersections, and when you start, doing hyperbola on top of hyperbola, might even have 4 intersections, or a parabola with an ellipse. So really what we're going to do is just go through a few examples here, and I do recommend that if you can, try and graph them, because that kind of gives you a clue as to how many solutions you're looking for. So this first equation here we see is a parabola. So this is y minus 3 equals 1/2 x minus 2 squared. So I have a vertex at 2, 3, 1, 2, 3. And I know that, now we don't actually have to draw it specifically, so we just know that the general orientation is going to be positive. So I'm just going to kind of go up, and I'm going to go up. Okay, so there's our parabola. Our other equation, hopefully you recognize this, is a line. So y-intercept is 5, 1, 2, 3, 4, 5. So right above the parabola. Slope is negative 4, 1, 2, 3, 4, minus 1, 2, 3, 4. So you're going to have it's going to be, how do I undo that? Okay. So we want it to be a lot steeper. That's kind of hard to draw. That was really bad. I'm sorry. I'm trying to draw this. Okay. Here we go. Go there and go up here. Okay. So you can see from the graph that it's going to intersect in 2 places, and it should be more straight, but sorry, It's the best I'm going to do right now. So we want to find those intersection points. So you have lots of possibilities. In this particular case, I might recommend, since y is isolated, that we substitute it in here and then just solve for x. So I'm going to come down here. I'm going to FOIL out this x, which gives me x squared minus 4x plus 4 equals 2 negative 4x plus 5 minus 3, and then distribute, so negative 8x plus, what was that, 2? So negative 8x plus 4, so x squared minus 4x plus 4, and then combine my like terms. So notice the 4's will cancel, and I can add 4 to the other side, so I have x squared plus 4x equals 0. If I factor out the x, remember never divide by your variables, I get that x equals 0 or x equals negative 4. So when x is 0, we have a solution. At this point, you can go back anywhere you want. The easiest is probably to go back to the equation of the line. When x is 0, we know y is 5. That will be one of my solutions. I almost hit it right on. And when x is negative 4, that's negative 16 plus 5, which is going to give me, wait a minute, did I say that right? So negative 4 times a negative 4, that's positive 16 plus 5, so that's going to be 21. And that sort of is verified by the graph. You're not giving your solution by the graph. The graph is more just to kind of verify how many solutions you expect to look for. Okay, so now this is where it could get potentially kind of crazy because of look at all these different intersections or potential non-intersections. So you also sometimes want to be creative in how you go about doing the algebra. So when I look at these two, let's go ahead and graph them so we get an idea of maybe how many intersections. So this first one is going to be an ellipse. So x squared, I'm going to divide everything by 36 over 9 minus y squared over 36 equals 1. Oh, I'm sorry, this is a hyperbola because of the negative in between. So my center's still at 0, 0. I'm going to go out 3 this direction. And did I count that right? 1, 2, 3. And then up 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And since I don't really care about, the asymptotes, and I'm really just more concerned with where the graph looks, it's coming off the x because the x is positive, and I'm just going to kind of follow where I know my asymptotes would be. So I can have a picture of what the graph would look like. So it looks something like that. Okay, this other one is going to be an ellipse with a center of 5, 0. So 1, 2, 3, 4, 5. And if we divided everything by 64, oh, I am so wrong. This is a circle because your coefficients are the same. So it is a circle that has been translated to 5, 0. And you have a radius of 8. So this was at 5, 6, 7, 8. That's going to hit right there. 1, 2, 3, 4, 5, 6, 7, 8. We're going to go off the charts. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. This is a really tiny grid. So my graph will look something like that, which tells me I expect to have 3 solutions because it looks like I have 3 intersection points. Okay, so now let's actually go through and find them. When I look at these two equations, I see lots of different things, but I see that my y squared terms are isolated and opposite. So I'm going to add the two equations together. So I have 4x squared plus x minus 5 squared. The y terms will cancel, and this will equal 100. And so I have 4x squared plus x squared minus 10x plus 25 equals 100. So 5x squared minus 10x minus 75 equals 0, and divide everything by 5 gives me 75 divided by 5, 15, and I can factor that. So a 5 and a 3, where the 5 is negative and the 3 is positive. So when x is 5 and when x is negative 3, those are the two solutions that I want. So when x is 5, and here again you can go back and plug it into whatever works. I'm going to plug it into the first equation. So if x is 5, I've got 25 times 4, which is 100 minus, so y squared is going to be 64, which means y will equal plus or minus 8, which that shows on our graph. So we have 5 and plus or minus 8. And when x is negative 3, I have 4 times 9, which is 36, so y squared equals 0, which means y equals 0, and that also shows on the graph. Okay? And then the last little bit is just, you can do an application where it's in terms of words. So we have the sum of the squares of two numbers is 45. So I would say x squared plus, since it's a sum, y squared equals 45. The sum of the first number, so that would be x, and the square of the second number, so x plus y squared is 39. And so what I might do to solve this is I'm going to subtract the two equations from each other so that I have x squared minus x equals 6, and then set it equal to 0. And this one, let's see, negative 3 and a 2, negative 3 plus 2. And so that tells me when x is 3, or when y is, sorry, not y, hello, come on. When x is 3, or when, I just did it again, I'm tired, x equals negative 2. Okay, so when x is 3, that gives me x squared is 9, so y squared equals 36. Which means that y will equal plus or minus 6. So we have 3 plus or minus 6, and if x is negative 2, then y squared equals 41, which means you have the coordinate negative 2 plus or minus square root of 41. Not pretty, but if you plug them back into the situation, it works. Okay, I hope that helps.